Okay, so this is going to be the pre-recorded video for 1.1. So in the live session, you'll be asked to share this in the chat room right here. So this right here would be in the chat room, and then to start looking at this. And then the next thing we were going to look at is just the Canvas survey and whether you've done it or not. I'm going to go ahead and just skip past those for this recorded session. So topic 1.1 is key features of functions. So getting started, ways to represent domain and range. We have interval notation and we have set notation. So we're going to go ahead and look at both. So here's our first example. All real numbers greater than or equal to 3 and less than or equal to 4. So they're bigger than or equal to 3, less than or equal to 4. So in this case, they're between 3 and 4, right? So for interval notation, we're going to have what's called a hard bracket. And we start at 3 and we said we're going to 4 and we're going to have another hard bracket. The reason we have these hard brackets is because of this little equal to part. Okay. And so then another way to write this here in set notation is going to be a curly bracket. And then we are going to use that we're looking at domain or just a number x. And it's an element of, and we said it's in between 3 and 4. And I'm going to go ahead and close the bracket. And we said that it's in between, so x is greater than or equal to 3, less than or equal to 4. Okay. So another way to visualize is we have a hard bracket. So again, this is a hard bracket. I'm going to erase the parenthesis because that's kind of going to be confusing in a second. So hard bracket, when it's included or equal to. Or we're going to have the greater than or equal sign with the line underneath. We're going to have a soft bracket, and that's why I erased the parenthesis sign just a second ago. If it's not included or not equal. And that would also have the greater than or equal sign without the line underneath. We also have a soft bracket when we're talking about infinity, just so that we're kind of a way to see it. So let's do one more and then I'll have you try some. So all real numbers greater than 3, so greater than 3, less than or equal to 4. So again, we're looking at 3 and 4. It can be equal to 4, so we're going to have a soft bracket. Hard bracket. But for the 3, there's no equal to, so that's going to be a soft bracket. And then set notation, we're looking at the same setup. X is an element of, so that's what this is saying right here. X is an element of. And then we're still at 3 and 4. It's still less than or equal to 4, but it's only greater than, so no line underneath. So go ahead and take a second and try the next two. Okay, so hopefully you tried those and we got something like this. So again, it's less than 3, so negative infinity to 3, and infinities are going to be the soft bracket. And then here you're just writing x is less than or equal to 3 after the set notation. And then greater than 4, so from 4 to infinity, and the same idea for the set notation. Example 1. So we're going to look at just writing domain and range. So I've already graphed the function for you. So this graph is showing y equals x squared minus 3, and we're just going to find the domain and the range. So the domain is the x values. So what can x be? Well, this goes on forever. And it goes all the way to the left and all the way to the right. So the domain would be all real numbers. So in interval notation, that would look like negative infinity to positive infinity. So again, this was interval notation. And then set notation would be that x is an element of, x is a real number. Okay, and then range, we're looking at the y values. So again, domain, we were looking at the x values. The range, we're going to be looking at the y values. So we see that it's not going to go past -3. So it goes from -3 up. So we're going to start with a hard bracket at -3 because it is included, and it goes all the way to infinity. And then set notation would be that y is an element and y is greater than or equal to -3. Okay, let's look at another one. An airplane or an air tanker flies over forest fires and drops water at a constant rate until its tank is empty. What is the domain and range of the function that represents the volume of water the air tanker can drop in X seconds? So it's got an 8,000 gallon tank, so it can hold 8,000 gallons. And it loses 40 or drops 400 gallons per second. So that's the important information here. So if we were talking about domain, that's how many gallons it can hold. So domain is the gallons, and time is going to be the range. So it can hold 8,000 gallons and it can't be negative. So domain would be from 0, a hard bracket, because it can have 0 gallons, it just can't have less. And then it can hold up to 8,000. And again, that's a hard bracket. So for set notation, x is an element and it goes from 0 to 8,000. Okay, and then time, well, we can't have negative time, so we can go from 0, not dropping any, or not having any to drop. And then if it's going to lose 400 for every second, 8,000 divided by, because it can only hold 8,000, and losing 400, we're going to divide those. So you can use a calculator, or you can do 80 divided by 4, which would be 20. So the max time it can drop is 20 seconds. And so again, we would just say y is an element of 0 to 20. Go ahead and try these. Okay, so if you tried those, you should have gotten something like the domain is all real numbers, and you can show it there. It starts at 0 and goes up forever. And then this one, it's kind of hard to tell, but it is 4.5 and it does hit that line. So it does have a hard bracket. Okay, example 2, we're going to be finding the x and y intercepts of this car that has a full tank of gas. The equation is here, and it relates the number of gallons of gas and the numbers of miles the car has traveled, and it wants to know what the x-intercepts and the y-intercepts are, so and what they represent. So if we remember, x-intercepts would be on the x-axis, and so that's when y equals 0. So we're going to take this equation and we're just going to plug in 0 for y. And so if I do that, I have this here, and then we're going to solve for x. So I'm going to subtract 16 on both sides. I get negative 16 equals negative 0.05x. And then I'm going to divide by my negative 0.05 on both sides. And then I'm going to get an answer of 320 equals x. So my x-intercept would be 320, 0. And then my y-intercept, same idea, except for it's on the y-axis, so now x equals 0. So y equals 16 minus 0.05x, and I'm going to put a 0 in for x now. So I have y equals 16. So my y-intercept would be 0, 16. And then it says, what do they represent in this situation? Well, at this situation here, it says that if my y is the left in the tank, gallons left in the tank after the number of miles, and x is the number of miles it's traveled, then at 0 miles, we'll have 16 gallons. After 320 miles, we'll have 0 gallons. Go ahead and try and find the x-intercepts of this equation right here. And here is the key for that. Okay, now we're going to look at for what intervals of this graph right here are positive, what intervals are negative. So where is y negative and where is it positive? So let's look here. Right here would be positive. And right here would be positive. So we're going to write those intervals. So from negative infinity to negative 3, and from 3 to positive infinity. And then where are they negative? Would be right here. And that would be from negative 3 to 3. Okay. For what values is it increasing? So we're looking for a positive slope. And so that would be from here on up. And then writing that would be from right here. So we're at 0 going on to infinity. And then where is it negative? It would be this part right here going down. That would be from negative infinity to 0 for negative. Or sorry, decreasing. That was increasing. Go ahead and try these. So here's the answers here. The one thing I want to point out is this one is decreasing the entire time, so there's no increasing, and then vice versa for this one here. Okay, and then the last thing is we are going to look at average rate of change. So you are used to seeing this.